So today we will be discussing about the stack operation, which will be performed in 8085 programming. So we have already discussed that for doing stack operation, what kind of instructions are being used. So we have seen that push and the pop operation, push and the pop instructions are the two instructions which are used for stack operation. I'm again repeating what is a stack. Stack is a kind of arrangement in which the data are temporarily stored in the memory location in a certain fashion, and that fashion is called first in, last out, meaning thereby the data which is inserted first can be taken out last. So the purpose of using the stack is to store the data while the program is being executed, to store the data or the result temporarily somewhere else in the memory location. And whenever it is required to use that data, retrieve that data from the stack. So that is why we use two operations, two instructions, push and pop. Push instruction is used to store the data of the register pair into the stack, and pop operation is the instruction by which we can retrieve the data which is already stored in the stack. But before we are going to use the stack, before we are going to store the data into the stack, it is necessary that the data which will be stored in the stack will be in somewhere in some memory location. So that memory location must be stored in a register pair that is called stack pointer. The purpose of using the stack pointer is to show the address of the stack top location. Why we always called stack top location? Because a stack is a kind of the arrangement in which the data is being inserted from the top. So whatever address is being represented by stack pointer, at that address, the data will be inserted or the data will be retrieved. Meaning thereby, whether we want to do push operation, that is storing of the data into the stack, or we are doing pop operation, that is retrieving of the data from the stack, it is necessary that there must be valid memory address of the stack in the stack pointer. So that is why it is always advisable to initialize the stack pointer by a 16-bit address so that push and the pop operations can be performed. So now, since we are discussing the stack right now, so going ahead with an example how the stack will be used. Suppose we have a program which is written like this at a certain memory location. Suppose that memory location is 2000, and at that memory location an instruction has been written LXI SP 2400. Since we want to show, with this example we want to show how the stack is operated So it is necessary that stack pointer must be initialized by an address. Suppose here it is 2400. So it means 2400 will be stored in the stack pointer. Now, you all, in the last lecture, I have explained that how to use the push operation and the pop operation. Push operation is used along with the register pair, and pop operation is also used with the register pair. So the first instruction in this example is written LXI SP2400. And after execution of this instruction is a 3-byte instruction. So it will take 3 memory locations to store that instruction. That is 2000, 2001, and 2002. That is why the next instruction is written at 2003. So at 2000, I have written LXI SP2400. So what it will do, it will copy the content that is 2400 in stack pointer. The lower order is 00, the higher order is 24. The next instruction is 2003, written at 2003, and that is LXIH2150. What this instruction is going to do, this instruction is going to load 2150 in the HL pair register immediately, meaning thereby H register will contain 21 and L register will contain the 50. Next instruction, since this instruction is also 3-byte instruction, so 2003, 2004, and 2005 will be consumed in writing the instruction. So that is why the next instruction is written at 2006. That is LXIB 28080. So what this instruction will do, it will copy, it will immediately load 2280 into the BC pair register. So BC pair register will be loaded by 2280. C register will contain 80 and B register will contain 22. So in this way, these 3 instructions are going to load a 16-bit number immediately. First instruction is going to load 16-bit number, that is the address of a memory, which is to be used as a memory, as a stack in the stack pointer. Second one is the data 2150 is loaded in the HL pair. And third one is the BC pair, which is loaded with 2280. So after execution of these 3 instructions, this will be the status of the register organization of microprocessor. SP will have 2400, H will have 21, L will have 50, B will have 22, and C will have 80. Now, at 2009, why 2009? Because 6, 7, 8, 3 memory location will be used for writing this instruction. So 2009 is written move AM. What this instruction will do, it will copy the content of memory into the accumulator. Which memory? Whose address is defined in HL pair. What is the address defined in HL pair? Is 2150. So whatever is the content of 2150, it will be copied in the accumulator. So after this, A register will contain the 8-bit number, which is stored in a memory location 2150. Now this instruction is single byte instruction. That is why 2009, after 2009, I have written 2008. At 2008, instruction is written push H. Now what is the purpose of this instruction? The purpose of this instruction is to store the content of HL pair. HL pair means content of H register as well as content of L register into the memory. Which memory? Which is identified by the stack pointer. because push always work with the stack. So purpose of push H, we want to copy the content of L register, H register into the stack. Since H register and L register are 16-bit registers, individually 8-bit registers, so it means we want to copy two 8-bit numbers into the memory. So it will require two memory locations. And as explained in the previous lecture, what is the meaning of push H? How it works? First of all, whenever push H instruction is being executed, first of all, the stack pointer content is decremented by 1. The stack pointer content is 2400. So first of all, the stack pointer content is decremented by 1. Whenever stack pointer content is decremented by 1, this 2400 will be decremented by 1. So it will become 23FF. Why? Because when you subtract 1 from 2400, you will be getting 23FF. Now 23FF will be the stack top location, which is represented by stack pointer, because you have decremented the content of a stack pointer by 1. So a stack pointer will become 23FF. And at 23FF memory location, the content of H register will be stored. And again, the stack pointer content is again decremented by 1, so that it will become 23FE. And when it becomes 23FE, the content of L register will be copied in 23FE. So meaning thereby, by using push H instruction, we have stored the content of H register and L register into two subsequent memory locations. First one, H register content in 23FF and L register content in 23FE. And since push instruction always starts by decrementing first the stack pointer content and then storing the content of the higher order register into the memory, and then again it is decrementing the stack pointer content by 1, so that it will become 23FE, and then copies the content of L register into that memory location, which is represented by stack point. So after the execution of push H, H register content and L register content will be copied into the stack at the location H register content is present in 23FF and L register content is present in 23FE. And since after the execution of push H, stack pointer will be 23FE. So it means the stack top location is right now 23FE. Again, at next instruction, next address, we have written push B. It means we again want to copy the BC pair content into the stack. Now, before push B, the stack pointer was having the content 23FE. Now, whenever push instruction is executed, for example, push B, first of all, the stack pointer content is decremented by 1, so that 23FE will become 23FD. And the content of higher order register, BC pair में higher order register कौन सा है? B. So the content of B register will be stored at 23FD. Again, the content of stack pointer is decremented by 1, so that it will become 23FC. And at 23FC, the content of C register will be stored. So after the execution of push B, the stack pointer will contain 23FC. Please mind it. Now, in the next address, we have written another instruction, push PSW. It means we want to push the program status word. We want to store the program status word in the memory, in the stack, from the stack top location 23FC. So whenever this push instruction is executed, push PSW, first of all, the content of stack pointer is decremented by 1, so that 23FC will become 23FB, and the content of higher order register of PSW. Now, PSW is a program status word. Program status word is a combination of accumulator plus flag register. Out of these two, accumulator is set to be the higher order register of PSW, and flag status register is the lower order register. So the content of accumulator is first copied at 23FB, and then stack pointer is again decremented by 1, so that it will become 23FA, and at 23FA the content of flag register will be stored. Now after this, after many lines which has been written in between, the 2020 is representing push PSW, pop PSW. Now what I want with this instruction, I want to fetch the top two stack locations into the program status word. Now, as I told you earlier, push instruction and pop instruction are counterpart of each other. Push instruction used to store the data of the register pair into the memory that is used as a stack. Similarly, pop instruction is used to retrieve the data from the memory which is used as a stack into the register pair. So what we want here the register pair to be accumulator plus the flag register. So that is why I have written pop PSW. Now the property of pop instruction is whatever is the stack top location, the content of that stack top location is first copied into the lower order register, and then the stack pointer is incremented by 1, and the content of that stack top location is copied in the higher order register, and then the stack pointer is incremented by 1. So if you clearly see, and the difference between push operation and pop operation is, whenever push instruction is executed, the first operation which is performed is to decrement the content of the stack pointer and then store the content of the higher order register into the memory. Again, decrement the stack pointer and lower order register content is copied in the stack top location. But when pop operation is executed, first copying operation is done. Whatever is the stack top location is first copied in the lower order register, and then stack pointer is incremented by 1. And again, the content of the stack top location will be copied in the higher order register, and then the stack pointer is incremented by 1. So the difference between push and pop operation is, while doing push operation, first first stack pointer is decremented, and then copying operation is done. And copying operation is done in such a manner, first higher order register content is copied, then lower order content register is copied. But whenever we are doing pop operation, first of all, the content of the stack top location is copied in the lower order register, and then the stack pointer is incremented by 1. Then the content of the top location is copied in the higher order register, and then stack pointer is incremented by 1. So what this pop PSW is going to do, it is going to, now at this juncture 23FA is the stack pointer content. So 23FA पे जो भी content होगा, that will be first copied into the flag register. And then stack pointer is incremented by 1 so that it will become 23FB. And the content of 23FB will be copied in the higher order register. And again, the stack pointer is incremented by 1. So when pop PSW, before pop PSW was executed, the content of stack pointer was 23FA. But after the execution of pop PSW, the content of stack pointer will become 23FC, because 23FA content is copied in the lower order register. In stack pointer is incremented by 1 so that it will become 23FB. And then 23FB content is copied in the higher order register. And again, the stack pointer is incremented by 1 so that it will become 23FC. Now, and the next we have written pop B. So what does it do? What it will do? Before pop B, what is the content of stack pointer? 23FC. So whatever is the content of 23FC is first copied into the lower order register, and then stack pointer is incremented by 1 so that it will become 23FD. And the content of 23FD is copied in the B register, and then stack pointer is incremented by 1 so that it will become 23FE. So after a pop B operation, the content of top of the two stack is copied in the BC pair, and the stack top location will be showing 23FE. Now, whenever we do pop H instruction, whenever we execute this, at that particular moment of time, the content of a stack pointer is representing 23FE. Now, the content of 23FE will be copied in L register, and the stack pointer is again incremented by 1 so that it will become 23FF. And the content of 23FF will be copied in the higher order register, that is H register. And then the stack pointer is again incremented by 1 so that it will become 2400. So in this way, the stack operation used to work. Now this is the, this is the illustration by figure, how these instructions are being executed and what is happening. So first of all, stack pointer was loaded with 2400. Whenever we execute push H, first of all, stack pointer is decremented by 1 so that 23FF. So 23FF पे जो भी content होगा, suppose the content is 21. So what we'll do, whatever is the content of H register का content 21 है, that will be copied in 23FF. See, 21 is copied in 23FF. And then stack pointer is again decremented by 1 so that 23FE it will become, and 23FE will be loaded by 50, which is the content of lower order register. Similarly, when push B instruction is executed, the stack pointer will become 23FD, and the content of B register is copied into the 23FD, that is 22. And then again, the stack pointer is decremented by 1 so that it will become 23FC, and the content of C register will be, that is 80, that will be copied in 23FC. Whenever we are executing push PSW, at first the stack pointer content is decremented so that it will become 23FB, and the content of accumulator, suppose accumulator whatever it may be, it is copied in 23FB, and again the stack pointer is decremented by 1 so that it will become 23FA, and the content of flag register is copied in 23FA. So after the execution of push PSW, the stack pointer will be showing 23FA. Now here the explanation is written. The explanation is saying that when first line of the program is executed, SP stack pointer will be loaded by 2400. So 2400 is the stack top location. When the second line, that is LXIH 2150 is executed, 2150 is loaded in HL pair register. When the third line is executed, that is LXI B2200, LXI B2200 is executed. 2280 actually it is. 2280 is loaded in the BC pair register. When the fourth line move AM is executed, accumulator will be loaded by the content of memory location whose address is stored in the HL pair. Hence, whatever is the content of A2150, it will be loaded in the accumulator. When the fifth line of the program, that is push H, is executed, first of all, SP content means the stack pointer content is decremented by 1 so that it will become 23FF. And at that memory location, the content of H register, that is 21, is stored. Then stack pointer is again decremented by 1. So SP will become 23FE. And at that memory location, content of L register, that is 50H, will be stored. Now, when the sixth line of the program is executed, that is push B, first SP is decremented by 1 so that it will become 23FD. And at that location, the content of B register, that is 22H, is loaded. Then SP is again decremented by 1 so that it will become 23FC. And at that location, content of C register, that is 80, will be stored. When the seventh line of the program is executed, that is push PSW, first of all, the stack pointer is decremented by 1 so that it will become 23FP. And at that location, the content of accumulator is loaded. Again, the stack pointer is decremented by 1 and the content of the flag register is stored at the location. Now, I have already told you that by using any instruction, you cannot fetch the content of the stack flag register. You don't have any instruction by which you can fetch what is the content of the flag register. The only thing which you can do is that you can check whether the flag is set or not by using branching instructions. But you cannot store the value. But it is the stack operation, it is the push and the pop operation with which it is possible to store the content of the stack, to store the flag register content into the memory location, or it is also possible to store certain number into the flag register. There is no possibility at all besides using push and pop instruction. So that is why push and pop instructions are very important instructions as far as the fetching of the flag register or storing some content into the flag registers are concerned. So push PSW will be used to store the content of accumulator and the flag register into the memory, which is used as a stack pointer. Now, after the seventh line of is executed, the stack pointer will show its content as 23FA, as I have shown you. Now, when the pop PSW is executed, first of all, the content of the memory location, which is represented by SP, that is 23FA, is first loaded into the flag register, which is the lower order register of the PSW. And then SP content is incremented by 1. So you have seen that when we were using push instruction, first of all, the first operation which is performed is to decrement the stack pointer and then copying. In the case of pop, here you are seeing that first there is a copying operation and then incrementation operation. So first, while using pop, first the content of the memory is loaded into the lower order register, and then SP content is incremented by 1 so that it will become 23FB. And content of this memory location, that is 23FB, is loaded into the accumulator, which is the higher order register, and SP content is incremented by 1 so that it will become 23FC. Similarly, pop B instruction is executed. So first of all, whatever is the content of 23FC, it will be copied in the lower order register, that is C register, and then SP content is incremented by 1 so that it will become 23FD. And the content of 23FD is copied into the higher order register, that is B, and then the content of stack pointer is incremented by 1 so that it will become 23FE. And when the last instruction of that is executed, that is pop H instruction is executed, first of all, the content of 23FE, which is the stack top location, which is represented by the stack pointer, that is 23FE, is first copied in the lower order register of the HL pair, that is L register, and SP is incremented by 1 so that SP will become 23FF. And the content of 23FF is now copied in the higher order register, that is H register, and the content of stack pointer will become 2400. So whenever we initialize any address which has to be used as a stack, it remains empty. You have seen that in the beginning of the program, 2400 was stored in stack pointer. But whenever we were doing push operation, first of all, the stack pointer is decremented by 1. So it means you are starting storing of the data at one location below the stack top location. That was 2400. 2400 contains nothing. It is always done. The stack top location in the very beginning is always remains empty. Whenever we have to do the push operation or pop operation, whenever we have to do push operation, first of all, stack pointer is decremented by 1 and then copying operation is being done. And whenever we have to do pop operation, first of all, copying operation is being done and then we increment the content of stack pointer. So that is why it is always said that stack top location always remains empty and nothing is stored in that. That is all about the operation which is related with the stack, which is to be used in 8085 during the programming process.